Hello students, welcome back. Understanding reaction mechanisms is incredibly important as they reveal exactly how the reactants transform into final products. In this video, we are going to learn how to identify the reaction intermediates formed in the given chemical reaction. First, identify what are the groups present in the reactant molecule. This is a diene molecule and it is having two methyl groups. When HBr is added to the molecule, what will happen first? In order to understand, first dissociate this HBr molecule to H plus sign Br minus. Now, which of these two will attack the double bond? So for that, you need to know that the alkenes are electron rich molecules. Why do we consider them as electron rich? Because of the pi bond. The carbon-carbon pi bond, the electrons are loosely held. That means what? They can be easily given to the incoming electrophile. That's why the diene is considered as electron rich and it will attack the electrophile. Which is the electrophile here? Proton. Now we have two double bonds. So which among these two double bonds will pick up the proton? Whichever is more electron rich, that is going to attack the proton. So among the given two double bond, this double bond is electron rich. Why so? Because it is attached to two methyl groups. These methyl groups are electron donating groups through inductive effect and hyperconjugation. So it makes this double bond electron rich. Therefore, this is the double bond which is going to attack the proton. So how to write the first reaction intermediate? See, the molecule is neutral. When the neutral molecule accepts a positively charged species, we have to get a carbocation. But where the carbocation should be there, on this carbon or this carbon? For that, you just understand that it is obeying Marconi's rule. The carbon with more number of hydrogen. So you see here, this carbon is attached to hydrogen. What about here? No hydrogens on this carbon directly. Therefore, the pi electrons are given to the proton through this bond. So how do you write the first reaction intermediate? Write down the carbon skeleton as it is first. You see, the electrons are given through this carbon. That means what? The pi bond is forming bond with this hydrogen like this. And where will be the carbocation? Over here. Why this carbocation is formed? Because it is tertiary carbocation. If the carbocation would have formed here, it is secondary. And students remember, tertiary carbocation is more stable than secondary. Hence, we are going to get this as the first reaction intermediate. And do you see that anyway? Yes, we have it as option A, but not as option C. So you can ignore this. Now what should happen? Cyclization must take place. How the cyclization happens? You see the pi bond is electron rich as I told you earlier. The electron rich should attack the electron deficient and it will attack through this carbon because ultimately we have to get a cyclopropane derivative, right? Therefore, the pi electrons are given to the carbocation through this bond. So first what we can do, we will write three-membered ring first. You see this carbon is attached to two methyl groups like this. What do we have here? CH2. This is the one. And through this carbon only it is forming bond. What about this carbon now? The CH2, the terminal carbon is deficit of electron. Therefore, it will be carbocation. This is the carbocation we got. Yes, it is primary carbocation, not so stable. What happens now? The bromide will attack it and form the final product what we have here. You see, this is the cyclopropane CH2Br. We have CH2Br over here. The adjacent carbon is attached to 2-methyl. This is exactly the same product what is shown over here. But look at this reaction intermediate. Where do we have it? So we have it as option B. Therefore, this is correct. Check for D. No, we don't get any such rearranged carbocation because if this happens, the bromide should attack here. So we should have a tertiary bromide. But the product what we have here is a primary bromide. Hence, there is no rearrangement. We are getting the carbocation what is shown here. That means option B. So among the given reaction intermediates, A and B are formed during the course of the reaction when the reactant is converted to the product. I hope I made this reaction mechanism question clear to you. And if you still have any questions, please do ask your queries in the comment section. And don't forget to like, share, and subscribe my channel. Thank you.